Okay, so this problem asks us if we fold this figure to a cube, so what is the largest sum of three numbers whose face come together at a corner? So this is like if we have this cube, and at this corner related to three face, like suppose there's 2, there's 3, there's 5. Then we say for this corner the sum is 2 plus 3 plus 5. So here the question is we want to find the largest one. We want to find the largest. So at first we should know at which point which corner can be largest. So largest three number could be 6, 5, 4. This is largest. Or 3, 5, 3. Okay. Oh, no, 6, 5, 3. So 6, 5, 2, like that. So we say so can we have this? So we wanted to make this. So let's say make a box. Suppose so we use the suppose this. We just use this face us. So this is, let's say, put this 2. Then we just put this other there's 4 square to form. Okay, so let's say there's 2, so there's 4, 5 go to here, so 6 go to here, right? So 2, 4, 5, 6. Okay, and the top is 1 and the bottom is 3. Okay, so we need to find at 4. Let's see, 2, 4, 5, 6. So we find at this corner. At this corner, 2, 4, 5, 6. At that corner, this one, right? This corner actually, this one, this corner, no, 2 is, let's say 2. So there's a corner 2. Then there's 6. There's 5, 3. Okay. So at let's say this corner. So this face, let's this side, this 1, 6, and like we have like this 1, 6, and this one 5, and the bottom one, this one 3. Okay, so we have 6 plus 5 plus 3. So this is the largest. This is the largest. So 6, 4, 5 cannot be together. Okay. So the answer should be, let's say, 14, right? 14. So for this problem, we want to find the total number of smaller curves that must have at least one face is shared. So we have 3 levels. So first level, we have 9 of 9 small curves. So we say this 2 is black. At least so this 2 has at least one face is black. And then there's 2, so then there's 2, right? There's 2. So here the question is for each face of the large curve, the opposite face is shared the same way. So like this face and that face, opposite side face the same. So we have black here, then black here. Okay, so then these 2 should be black, and this one is black here, and we have this black, then this black, we have here this black, then so that one is also a face black, so this one. So for first level we have 7. So let's check the second level. So we can see second level is this one, so this means like this one. Okay, this one is black. This curve have one face black. So then this one, yeah. And we have this 2. So then this 2. So this 2. Okay, so we have 6. And for the bottom level 3, okay, so here we have this 2, so this 2, and this one, so this one. Oh, so this one, then this one. So this 2, then this 2. And because here we have one black, so then this one also should be. So that one black. Okay, so this is, we have 7. Okay, as a totally add them up, we have 20. So for this problem, it says like we already have this 4 attached square. We have this 4 attached square. This attached square make a T-shape, right? So then we just attach one square. Suppose that if we attach this A, so question is, can we make a box, a topless box? So this one, so this is easy. Like if we have this 4 square, the 4 square we put the like let's say we have this 4 square, okay, and here attached. So this one we can make a box, right? For this 4, we can make this like this 4. Then one is one side, the so other one face, the other face is we say topless. We can make a box. Okay. So let's say, so which one cannot make a box? So we say suppose that we have a box. We have this topless box. So we just cut it, then we can display it. So we have like this, say like it is this is a square. So we can add here, right? Here. If we can put the box in a flat, make a box flat, so we can have that. So we find at those points, at the corner, at most have 3 faces, right? And we can say like if we have these 4 square put together, then one more square. So this one we cannot make a box. Okay, so this one we cannot make a box because like this corner we have 4 square, right? So at the most 3 square, cannot be 4. So this one cannot make a box. So we can say like, oh, okay. So if we, so A is okay, so B, if we say B, so B is also okay. So how about C? C, so if the C, so C is become like that, right? So C not okay. Then G also should not okay. C or G same. So all others are okay. So only C and G not okay, right? So how many ways? How many? So we say we just count A, B, C, D, E. Let's say how many? So we just a minus 2, right? So we have 6. That is 8 case A, B, C, D, E, F, G, H, so minus 2. So we have 6 ways we can make it a topless box. Okay. So this problem says a piece of paper contains 6 joined square labeled as A, X, Y, Z, U, V, W. Okay. So we want to find the label of the face opposite the face label X is which one? Okay, so we just put, let's just make a box. We just put V as the bottom. So that's V. Okay, we put a V as bottom. V. So then so W. So W here. W. And we just make this, put this 3 squares this way. At V is bottom. So V, so here's U, right? So here is W. Okay? U, V, W. Okay. Okay. So where's X? So X can be only this one, face as X, right? U, V, W. Okay. So let's say again. So here this is V, this is U, and this one is W. W go to here, and X. So X go to here. X. So Z go to top, and Y go to here. Y. Right? Okay, so we say face to X, Y. Okay. Okay, so now let's check some other examples. So it says this one, a square shaped 4 is covered with congruent square tiles. So let's check some small numbers. So let's say like if we have, okay, okay, like here, so this one is tied by a small square. Okay, so in here we say number for diagonals. So number of diagonals, so this. And also so in this case, if we can say like if side n, we can look at a if n equals 4, number of total number of tiles that lie on the two diagonal is 8, right? So we say this n is 8. Okay, so let's check one more. So if 1, 2, if n equals 5, 1, 2, 3, 4, 5. So let's check n equals 5. So 1, 2, 3, 4, 5. Okay. Okay. So number of diagonals, this one, 5. And this, okay, 5. But here, this one is overlap. So we say in this case, n actually not equal 2 times 5 equal 2 times 9 actually equal 2 times 5 minus 1, right? So from here we can say if the side of a big square is even number, then number of tiles on the two diagonals is just 2n. If n is odd number, then 2n minus 1. So this is the total number. This is 37. So we can find n. What is n? So we say by number a, big N is 37. So what is n? So we know this n equal 2n minus 1, right? 2n minus 1 equal 37. So we find n equal 19, right? Okay, so how many tiles? So number of tiles equal n squared, equal 19 squared. Okay, so for this problem, we want to find the area of this quadrilateral ABCD. ABCD. Okay, so this is let's say BCD. This angle is a right angle. BCD. So let's connect this. Okay, so saying this triangle BDC or BCD is right triangle, right? Right triangle. Okay, so let's say so AB equal 12. Okay, and BC equal 4. CD equals 3. So 3, 4. So we know DB is 5, and we know DA is 13, right? 3, 4, 5, and 2, 5, 12, 13. Okay, so we can say this the area equal big right triangle. That's 3, 4, 5, 12. Okay, so this area equal, let's say, half 5 multiplied 12 minus half 3 times 4. Okay, now let's move to this problem. This is in the right triangle ABC. AC equal 12, BC equal 5. So AB equals 13, right? So this is a 5, 12, 13 right triangle. Okay, and this is angle C is right angle. So it says a semicircle is inscribed in the triangle as shown. So what is radius? We want to find the radius of this. Okay, so now suppose the center is here, and so there's a tangent, right? Tangent. So this is right angle. Okay, so we want to find this R. So we don't know where is this point O, or not so easy to find it. But here we want to find this R. So let's say okay. Okay, so suppose this R, then this R, okay, and so because of this BC, and so we know this B to this point, suppose we put this as ABCD. Okay, so BD, BC same, so BC, BD is also 5. So we know what is AD. AD equal AB 13 minus 5. So 13 minus 5, 8. This is 8. Okay. Okay. So here we have this. Let's say so we have large triangle. We say RT triangle, triangle ADO, ADO. Say triangle and say the triangle ABC. Say the two large triangle is similar. So we have this. We say so R over A, R over 8. This is for this ratio from this small large triangle, right? R over A, so equal. We can find R over A equal is 5 over 5 over 12. Let's say so we have this like so R over A is this large triangle, and for this angles opposite side of this, so R over 8. So this equal this 5 over 12. So from here we can find this R, right? R equal to 5 times 8 over 12. We can simplify here. 2, 4, 2, 3. Okay, so R equal 10 over 3. Okay, for this problem, this is a simple so-called is inscribed in an isosceles triangle with base 16 and height 15. Okay, so say the base is 16, so we put this. Okay, so this one, so we put this. Oh, okay, so this is become 8, right? 8. And height, this is a 15. Okay. So we want to find radius. Okay, so suppose there's a point. Okay, so we want to find this R. Okay. 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 So the key point is this is large triangle, large triangle, large triangle. we put this, okay, suppose this A, O, so this point is A, O, B, suppose this is C, this point is D. Okay, so the key point for such a problem is this. So we have this three large triangle. Triangle, let's say AOB. AOB, triangle AOD, and triangle OBD. So these three triangles are similar. So this is the key point. So why is there similar? So because their angles are same, like, so one is 90, and let's say like, so this angle plus this angle is 90, and so we say this angle plus this angle is also 90. So we say this angle like this one same. So we say these three large triangles are similar. Okay, so then based on this, so we can find the relationship about R, and we can find this R. So let's say, so we just check, okay, we just check AOD, we just say AOD, we just simply say triangle AOD and large triangle OBD. OBD is similar. So we say R over 15. So R over 15 is this ratio for this small angles opposite side of hypotenuse. R over 15 equal R over 15. This way. This is okay, but we can have a simple way. We say for large triangle. Okay. So this is R. So we say this is 8. This is 15. So we can find AB. So AB square equal 15 square plus A square, right? So we can find AB. So from the area we say this AB multiply R equal 15 multiply 8, because the area same, right? So if we say this is a large angle, if we use this large angle, so area is half of 8 times 15, so equal AB times multiply R. So from here, this way, we can find R. Okay, so we can stop here and we will continue.